All right, welcome back, chemistry fans. Today we are going to do your homework topic 2.5. I believe this is Lewis structure electron dots. So let's jump right into it. Let me share my screen and we shall begin. So in this, you have silicon. It's asking for its electron dot structure. So we have to know what element silicon is to do that. So let's go and try and find that that element. Silicon over here, it is element number 14 on the right side. Coincidentally, it's on the 14th column, meaning that it's going to have 4 valence electrons. So let's jump back to the question, see if we can make heads or tails of what that means. So for the electron dot structure, it's not the Bohr model. We don't put all the electrons, just the valence electrons. We will always put 2 at the top, and those represent the first 2 electrons from the s sublevel. And then we will do Hund's rule, and we will put 1 on each of the corners. It doesn't matter if you start on the left or the right or the bottom, but they can't be together for the electron dot. All right. Then comes AS, F3. And so we're going to have to go and learn how many valence electrons each of these elements have. So let's try and figure that out. AS is in the 15th column, so it's going to have 5 valence electrons right here. Fluorines are right underneath my head over here. They're going to have 7 valence electrons. So let's try and utilize that information. So I've got 7 dots. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then the arsenic are going to have 5 dots. 1, 2, 3, 4, 5. So if you draw the structure out, it's foolproof. You can't mistake it. If you know how to count the valence electrons, you will be fine. Now on the next one, this is where we need to employ a want minus have. And I'm not sure if we will get to this today, but if we don't, that's okay. So sulfurs and oxygens each have 6 valence electrons. They all want 8. So there are 4 of these atoms in total. There are 3 oxygens and 1 sulfur. So if I have, we count these out. So I've got 8, 8, 8, and 8. That is a total of 32. Now, how many they have? They are in the 16th column of the periodic table. So they are going to have each 6 valence electrons. So we'll utilize that now to get 24. The difference of those 2 values is 8. Divide that by 2, and that tells us that there are going to be 4 bonds. The first element always goes in the middle. It does not matter if you place the double bond on the right side, if you place it on the center, or if you place it on the right side. It does not matter. It's your preference. Those are all equal positions for that double bond. They call this resonance. Okay, so with that said, then we need to fill in the rest of the unshared electrons. With the bond over here, we would have 2. The double bond, we would have 2. With each of the other bonds, we would have 6. And the sulfur has got a stable octet. It doesn't need anymore. And you're saying, well, are we just putting in electrons? Well, let's make sure, because we have 24 to count. So let's count what we have got out here. Let me change my color so we can distinguish it. So I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, which is what we were supposed to have. So this is our homework. This is our answers. Thank you for stopping by. Hopefully it was not too terribly challenging for you. Talk to you again soon. Bye-bye.